students, welcome to 512. The good news about this lesson is you are not learning anything new today in particular. What you are looking at instead is how do you know what to use when? How do you know when you're supposed to use sine versus cosine versus tangent? This is just kind of a practice day is what this is. And so if you take a look, they give you a little bit in this lesson about when to use sine versus cosine versus tangent. And if I go through and just kind of highlight that. So cosine is when we're dealing with the adjacent leg. So there's your adjacent leg and there's your hypotenuse. When those are the two pieces you're working with, you know that that is a cosine problem. That's what we're talking about. Okay? If your theta is here, this then is the leg opposite theta, and this is the hypotenuse of the triangle. Therefore, that is when you use sine. And what we started with was tangent. That, if you remember, that was your ratio of opposite leg to adjacent leg. Those two pieces. If you're working with the two legs, you know that you've got a tangent problem. Okay? And so the idea behind this section is just giving you some practice on what do I do when. Okay? So if we take a look at some of these problems down here, I'll take a look and I'll do a couple of these together, and then I want you to do the rest of them kind of on your own and see how you do. And we'll go over the questions in class on when I see you. Okay? So if we take a look at part A here, for example, if you notice, the 28 degrees is my angle, my theta that I'm going to be using. And if you notice, the two pieces that I'm dealing with here are the x is the opposite of that 28 degree angle, and the 19 is the hypotenuse of the triangle. So if I look back and figure out which one of these ratios deals with opposite leg and hypotenuse, that's the idea right here, where there's your opposite and hypotenuse, there's your sine type of problem, what we're doing. Okay? One of the other ways to remember this, you may have heard in the past of this idea of what's called SOHCAHTOA. Okay? It's just an acronym to try to help you remember what goes with what. Okay? And here's the idea of SOHCAHTOA. It's SOHCAHTOA. And what that's referring to is S stands for sine, is opposite over hypotenuse. C stands for cosine, is adjacent leg over hypotenuse. And T stands for tangent, which is the opposite leg over the adjacent leg. Okay? So SOHCAHTOA is just a way basically to remember what we have up here. If you think of SOHCAHTOA. So if we take a look at this down here, we're going to try to go through and solve for this. So we said I've got opposite and hypotenuse. That is the sine portion. So if we do this off to the side, I'm going to set up sine of 28 degrees over 1 equal to, by definition, or the ratio of sine is the opposite leg to the hypotenuse, which means I've got x over 19. Okay, that's the work that we're going with. So now I cross multiply. X times 1 gives you x equal to 19 times the sine of 28. And the nice part about this one is that the x is already all by itself. I don't have to worry about doing any solving for that, and therefore we can go through and we can just type that into the calculator. The variable's already solved for. So in this problem, x is going to equal approximately, if we type this in, 19 times the sine of 28, I get 8.92 approximately, if I round that to the nearest hundredth. Okay? So there's our answer for the first one. You identify it as a sine ratio, we set it up, solve the proportion. Okay? Second problem here actually should be an easier one, because if you notice, you got a 45 degree angle, and remember, that means this is also a 45 degree angle, which means this is a 1-to-1 ratio. This is an isosceles triangle. Therefore, in this case, I know right away that x equals 8. I don't have to set anything up. I could have used the tangent if I wanted to solve for that, but hopefully you just remember that a 45 degree angle is a 1-to-1 ratio. Okay? And then if we take a look here in part C, 61 is my angle of theta, my theta that I'm going to use in this problem. And what we are looking at is the 18, if you notice, that is the adjacent leg, and x is the hypotenuse of this triangle. So the one that deals with adjacent and hypotenuse, if we come back up here, there's the AH, therefore this is a cosine. There it is written out a little bit more. Cosine is the adjacent to hypotenuse ratio. So now if I go through and set this problem up, I would take the cosine of 61 over 1, and that equals, by definition, it's the adjacent to hypotenuse ratio. Adjacent is 18, hypotenuse is x, and now we can go through and I can solve this ratio. If I cross multiply, I get x times the cosine of 61 equal to 18 times 1, which is 18. And now on this one, unlike here in part A, when I cross multiplied, the x was already by itself. In this problem, I got to get x by itself. I need to go through and get rid of that cosine of 61. So since I'm multiplying by the cosine of 61 in the problem, we're going to divide by the cosine of 61 to get rid of it. Same thing on the other side, cosine of 61. Those will cancel, and therefore now I've got x equals, and this is what I'm now going to type into the calculator. 18 divided by the cosine of 61. I go ahead and hit enter, and I find out that that hypotenuse has a length of approximately 37.13 if I round it to the nearest hundredths place. Okay? So there's an example of a sine example. Here's a cosine example. The first one had the x in the numerator, so I didn't have to solve for anything. The second, this part C here, had x in the denominator, so I did have to solve for some stuff. And so there's a little bit of everything that you need to see here. The only thing we didn't really do much of was tangent. But what I want you to do then for this lesson is I want you to try these other ones on your own and see if you can figure out whether you use sine, whether you use cosine, whether you use tangent, and see if you can also solve it. These are the questions then that we will go over in class and make sure that you're understanding and make sure that you're doing okay. Okay? So bring any of those questions with you to class. Otherwise, if we take a look and we move forward here in this lesson, notice it says Marta arrived for her geometry test only to find that she forgot her calculator. So she decided to complete as much of each problem as she could. Okay? On the first problem of the test, she was asked to find the length of x in this triangle at the right. And so this is what she wrote down. They kind of want you just to explain this. So if you notice, she wrote sine of 25 equals 29 over x. Well, if we notice, let's check. 29 is the opposite leg. X is the hypotenuse. So that is a sine problem. Okay. 29 is the opposite. X is the hypotenuse. So she set up the ratio correctly of opposite to hypotenuse. And then if you just go through and cross multiply, this is what you get. She then divided both sides by sine of 25 to get x by itself. And therefore, if she had her calculator, this is now what she would type into that calculator. Okay? So if you notice, this is what's called an exact answer. But we want to obviously go further than that because I don't want x to equal 29 over the sine of 25. I want to actually go through and get an actual length for that. So you type that into the calculator and round it. Okay? If you take a look at part C, though, here's the last thing that I want you to take a look at. Notice it says Marta's teammate Ziv said he solved it differently, but still got the same answer. He started with the equation cosine of 65 equals 29 over x, and we got to explain why that still works. So if you look back up at this problem, what I want you to notice is if you were to solve for the third angle, this is the 65-degree angle that he's using. And then, therefore, that makes 29 the adjacent leg, and x is still the hypotenuse, which is a cosine problem. Okay? So he also set this up correctly and would end up with the exact same answer that Marta had here in part A. Okay? So you can use either one of these two acute angles. It does not matter. One of them in this case gave you a sine problem. The other one gave you a cosine problem. There's a reason why it's called cosine, because it's a kind of sine's partner, if you will. It goes with sine. So that's the idea, is that these two angles will always kind of work together. You could get the same answer using either one. So down here in part D, if we just kind of practice that, notice they say we want to solve for y in two ways, using both sine and cosine. So if we were to do that, let me go through, and if this is the angle that I'm using, 53, that means y is opposite that angle, 5 is the hypotenuse because it's opposite the 90. So opposite and hypotenuse is a sine problem. I could set this up as the sine of 53 over 1 equal to y over 5. Opposite leg over hypotenuse, and then I could go through and solve from there. The other option is I could solve for the missing angle in this picture, and if I do that, I would end up with, let me think, 37 degrees. So this would be a 37 degree angle, and if that's the angle I'm now using as my theta, that means y now is the adjacent side, 5 is still the hypotenuse. But adjacent and hypotenuse deal with cosine. So the cosine of 37 over 1 would equal the adjacent leg over the hypotenuse. And if you solved that one, in this case, regardless of which way you solve this, you would end up with the exact same answer either way. Okay? And that's what they wanted you to start to see in that portion. So if we take a look on the last part, if you notice, this is kind of starting to take a look at the next section. So notice it says you use trig tools to find side lengths, but do we have a way to find angle measures? Examine the triangles below. Do any of them look familiar? Can we use any information about side lengths? And so the idea that they want you to come up with on this one, we're not going to spend a lot of time on this yet, but the idea that they're coming up with is they want you to recognize that in part A, notice we've got a 1-to-1 ratio. Therefore, in that case, theta has to be a 45 degree angle. Okay? If you remember back to the first lesson back in chapter 4, if this is theta, this is now, I've got a 1-to-5 ratio, which means in that case, if you remember back, that means theta has to be approximately an 11 degree angle. Okay? And the last part, we talked about this in the last lesson in 5.1.1. In the 5 is the adjacent compared to the hypotenuse. That adjacent to hypotenuse ratio is 5 over 10. And that happened in the cosine. If you remember, that was when theta was a 60 degree angle. Okay? So this is kind of setting up the next section where we can use all these sine, cosine, tangent ratios in order to find the angle measures. For now, I just kind of want you to think about that and work your way through that. But then eventually in this next section, we're going to actually go through the specifics of how you solve for that, regardless of whether it's sine, cosine, or tangent. So you don't have to memorize all these different angle ratios. Okay? With that being said, here is a really good math notes box that quite simply explains everything. Here's your tangent ratio. There's your sine and cosine ratio. Talks about opposite versus adjacent versus hypotenuse, and how you figure out which one is which and all those kind of things. So this is a trigonometric ratios math notes box that talks about everything that we've referred to so far in trigonometry. Okay, so if you're struggling with anything, I would recommend you take a look and read through this because it does a really good job of explaining everything. Okay, your practice to learn for this lesson is as usual is 5.1.2. 517 to 523. However, you can skip problem 520. Okay, give that a shot. Good luck, and we will go over all of your questions in class when I see you next. Okay, good luck, everybody.